Throughout the past century, mankind has celebrated many major breakthroughs in astronomy, especially in space travel. But what lies behind these successes are the negative impacts on many astronauts that mainly include the loss in bone and muscle mass, reduced cardiac function, disrupted sleep cycle, and weakening of immune system. Humans rely on gravity to develop stronger muscles and bones. When carrying weights in the gym on Earth, humans rely on the gravity pull to grow muscles by resisting. However, in space, the reduced resistance due to absence of gravity caused muscles and bones to deteriorate slowly. In fact, such a problem occurs on Earth as well, on inactive elderly or human with related illnesses. Patients on prolonged bed rest suffers from muscle atrophy, bone density loss, and changes in metabolism, similar to the effects of a long-duration spaceflight. Moreover, astronauts lose bone mass quicker than humans on Earth. For example, an untreated postmenopausal woman can lose up to 1.5% of bone mass in 1 year, while an astronaut can lose the same amount in 1 month. In order to potentially tackle the problem of bone and muscle mass loss, the Japan Aerospace Exploration Agency are carrying out 2 investigations on the International Space Station. These studies revolve around a millimeter-long roundworm that is widely used as a model for larger organisms. These research done by astronauts will involve growing multiple generations of the worm so different stages of development can be compared. The aims of these research are: number 1, clarify how and why these changes to health take place in microgravity, and 2, determine if the adaptations to space are transmitted from one cell generation to another without changing the basic DNA of an organism. The first study will look into the muscle fibers and cytoskeleton of the roundworm to clarify how its physiological systems will alter in response to microgravity. Space station crew members will grow these worms in 2 batches, one in microgravity and another one in 1G using a centrifuge. This will simulate the force of gravity while the worms remain physically in orbit, allowing a direct comparison of the effects of different gravity levels on organisms in space. It is scheduled for launch to the station on the SpaceX 6th Space Station Resupply mission in 2015. The second ongoing study takes a much closer look at worm by examining their DNA. It requires astronauts on the orbiting laboratory to grow 4 generations of the worm, with adults and larvae from each generation preserved at different points during their lifespan. These worms will return to Earth from space station in the SpaceX Dragon spacecraft in January. In conclusion, the research on battling muscle and bone loss brings about 2 main impacts. Firstly, the results of the investigation could lead to new treatments for bone and muscle loss in humans living in space. By having treatments and solutions, it impacts largely on astronauts on deep space mission, possibly reducing the detrimental effects significantly. Humans can then stay longer and travel further in space, breaking the 2.2 years record set by a Russian astronaut. As the brightest minds work on the most complex problems faced by astronauts in space exploration, solutions are often adapted to solving real-life situations which benefit mankind. For example, the technology for NASA's space shuttle and robots has been adapted to create more artificial functional limbs. The billions of dollars are definitely well spent, creating a mutual benefit both to space exploration and life on Earth. This article caught my attention because it reported that worms are used for space research. It is surprising, as I would always relate scientific research to conventional means, such as monkeys or mice. Upon deeper research, I learned that this species of roundworm is commonly used not only because it is cheap and easy to grow, but most importantly, generations can be bred once every 3 days. Moreover, these worms have similar systems as other animals, making it a great model organism choice. This research left me thinking if its physiological system will behave the same way as on Moon and other planets. Should one day humans were to live on other planets, bone and mass loss might be a huge obstacle to overcome. I look forward to the findings as well as its future solutions, as it would mean that longer space explorations could be carried out, indirectly contributing to more space advancement.